So far we have seen range, variance, and standard deviation. So now we will be looking into the MAD. Don't worry, it's a mean absolute deviation. The mean absolute deviation is the average of the absolute differences between each data point and the mean. It represents the average amount of deviation of each data point from the mean, regardless of the direction of deviation. MAD is often used when the data set has outliers or when the absolute differences are more meaningful than the squared differences. And you can see the equation which is used to calculate a mean absolute deviation. So it's summation of absolute deviations of it's summation of absolute deviations. That's it. We have calculated the deviation, that is yi minus y bar. Here xi minus m of x, that is mean of x. And when you take the absolute of each deviation, so even the negative ones will also be converted into the positive. This is one way of suppressing the negative directional deviations. One is summing up, one is squaring up, the deviation. Second one is doing the absolute. So if you do the square up, that's called a variance. If you do the uh, absolute, if you put it into uh, absolute bracket, then it's called absolute deviation. So now if you divide the absolute deviation with the sample size or population size, that's called mean absolute deviation. So what all it consists of? M of x is the average value of the data set. N is the number of data values, size of the population, and xi is the data values in the set. This is uh, individual data value. So MAD is often used when the data set has outliers or when the absolute differences are more meaningful than the squared differences. Let's take one example here to understand the mean absolute deviation. So as we have discussed earlier, the mean absolute deviation is a measure of variability that calculates the average absolute difference between each data point and the mean of the data set. It gives an idea of how much the data points deviate on average from the mean. What does it give? Let me write down here. It gives an idea of how much the data points deviate on average from the mean. So in other words, it measures the average distance of each data point from mean. So it measures average distance of each point from the mean. So let's take the same example. So the data is the data frame that we have created earlier. So from this data frame, so to calculate the mean absolute deviation, you need to take the following. First, we have to calculate the mean and divide it by respective number of records. So let's calculate the mean first. So mean value is equal to data and use mean method. That's it. Yep, mean is 30. Now let's calculate the mean absolute deviation. MAD. So MAD value is equal to, so let's take an expression, data of A and so each data of A minus mean of mean value and let's put this whole thing, apply the absolute method and take the mean of it. So now print mean absolute deviation, that's MAD, is equal to MAD value. It's 12.4. That's the mean absolute deviation for this. This is 12.4. And the standard deviation also we have calculated. So if we just want to see the standard deviation here itself, so let me go for the data and it's here std, it's 15.81 is the standard deviation and then mean absolute deviation is a 12. So where would it be helpful, the standard deviation? So let's see that in this example we first calculate the mean of the A column in pandas data frame using the mean method. Then we subtract the mean from each data point using subtraction operator and take the absolute value of the result using absolute function. Finally, we calculate the mean of these absolute differences using the mean method. That's what we have did. So we have taken this and then we have applied an absolute function to it. Then at the end we have taken the mean of everything. So finally we calculate the mean of these absolute differences using mean function again, which gives us the MAD value, that's mean absolute deviation value. Know that the MAD is a measure of variability that's less sensitive to extreme values compared to measures like variance and standard deviation, as it only considers the absolute differences between the data points and the mean. So it's often used in situations where the data may have outliers or extreme values that can heavily influence other measures of variability. In those kind of situations only we will use this. I will repeat it again. So it is often used in situations where the data may have outliers or extreme values that can heavily influence other measures of variability. In that cases only we will take MAD. So let me take one more example. Let's do this calculation. This is a real world data for the players data, soccer players. height. But before that, let me calculate the mean value. Mean value players is equal to players height in centimeter dot mean and absolute. And finally, let's print that. Print mean absolute deviation, that's mad, is mad players. It's 147.45. That's what the mean absolute deviation. Okay, let me check the mean. Well, players, it's 177.45. Okay, this is the mean and the mad is 147 divided by this. Okay, mean of all. Okay, that's how we calculate the mean absolute deviation.